at data link layer. And what we do in Hamming code is we these redundancy bits are going to help us for error detection and correction, right? So suppose let me have example of a Hamming code calculation for 4-bit Hamming codes, right? So from the 4-bit data we need to add a 3 bits redundant bit. For a 4-bit data we need to add a 3 bits of redundant data, correct? So how do we decide this number of redundant bits? So this number of redundant bits are decided upon 2 raised to the power, right? So 2 raised to power 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So at these positions we are going to have the Hamming bits. Let us move ahead and see how the Hamming bits are generated for 4 bits of a data. So for 4 bits of a data we will be having the parity bits at a position 2 raised to 0, that is P1, then 2 raised to 1, that is P2, and 2 raised to 2, that is P4. Now this 2 raised to 3 is going to be P8. After that we are not going to have any data bits remaining for us, so we will not be considering that particular power and the powers next to that. So this is how we are going to calculate the positions of the parity bits. Fine. So looking at the data given over here, we can see that complete 7-bit block will look like this P1, P2 parity bits, D3 is a data bit, again P4 is a parity bit, D5 data bit, D6 again a data bit, and D7 is one more data bit. Fine. Now whenever we need to calculate this parity bits, whenever we are going to calculate the parity bit, we will be considering the data bits which are with us. So for a parity bit P1, we need a data bit D3, D5, D7. Now let me give you a clue of how to calculate this positions of data bits, right? Now when I am with P1, which I am with the position of 1, I will be taking the bits at position 1, 3, 5, 7, like this. So if my data is a huge number of a data, say I have a data of 8 or 9 bits, so every odd position bits will be calculated, responsible for calculation of parity bit P1. Are you getting this? So whenever I am supposed to calculate a parity bit for position P1, I will be taking bits at the position of every odd bit of a data. That is, for P1, I will be taking the number as D3, D5, D7. Fine. When I move for P2, I will be considering from P2 to 2 bits. So P2, P2, D3, then D4 or P4 and D5 will be escaped. So it's like we are considering 2 bits, omitting 2 bits, then considering next consecutive 2 bits, omitting next consecutive 2 bits. So like this we are going to follow the cycle. So currently I am considering P2 D3, omitting P4 D5, considering D6 D7. After D7 we do not have any bit available, so we are stopping over here. Whenever we go for the P4, what we do? So like this we will continue again. So from P4 we will consider 4 bits, then omit next 4 bits, consider next the bits after that, and omit next 4 bits. So in a consecutive cycles we will consider 4 bits in a consecutive cycle. So fine. So here we will consider P4, D5, D6, D7, right? We are supposed to omit D8, D9, D10, D11 if we are having those number of bits, and then consider the next consecutive bits. So like this, there is a clue of calculating or considering the bits for calculation of parity bits. Understood all of you? And then what we do, we make a even parity. So if these 3 bits are having odd number of ones, then we will take the parity bit as 1. If these 3 number of bits are having this, if the 3 bits are having even number of ones, then we will take that particular parity bit as a 0, as explained on the screen. So like this, see here my D3, D5, D7, see this is D3, D5, D7. So data at D3, D5, D7 is 1, 1, 1, right? 1, 1, 1, and that's the reason it is odd number of 1, so we consider this P1 as 1, right? Then when we go for P2, my data bits which we are considered for the P2 will be D3, D6 and D7. So D3 is 1, D6 is 0, and D7 is 1. Now this is having even number of ones, and that's the reason we are considering a 0 as this particular parity bit. So this P2 will be considered as 0. So likewise, we will be calculating these parity bits, and total we will have the data to be transmitted, or the code, or a complete 7 bit block for the transmission of a data. So these calculated parity bits will be appended at their position, and with the data bits this complete data will be transmitted to the receiver. At a receiver side, at a receiving side, whatever data is received will be again checked for the parity bits, right? So for this case, what we will be considering is P1 will be checked with P1, P3, P1, D3, D5, D7. So like this, we will be calculating P1. So as we can see that over here, I have received P1 as 1, D3 as 1, D5 as 1, and D7 is as 1. So this is my even parity. So P1 will be 0. For P2, what bits we consider? For P2, we consider P2, D3, P2, D3, escape P4 and D5, and then consider D6 and D7. Right? So here I am getting 1, 1, 1. So it is odd parity. So P2 will be denoted as 1. For P4, again, I will consider as P4, D5, D6, D7, which will be 1, 1, 1. Again, it is an odd parity. So P1 is considered as, P4 is considered as 1. Now this P1, P2, P4 will be returned like this. Correct? So P1, P2, P4. So it will be 1, 1, 0, which will be 6 in a decimal. How do we represent this 110? That is 6 in a decimal. So my sixth position went wrong while transmitting a data. Even you can see here, this sixth position has flipped out, right? So my sixth position went wrong while transmitting a data. So I am supposed to flip the sixth position, and this is how my error is detected in a Hamming code. Fine. So this is a theory behind Hamming code. Now let's look at a code. Okay. So let me share the Hamming code. Fine. So let me share the code now. Okay, so look at the code. This is my assignment for error detection and correction of ASCII codes using Hamming codes, correct? So here I will ask a user to enter 4 bits of data one by one. So I will be taking the data as we have seen the example of calculation of Hamming codes for 4 bit of a data. So the program is also generated for 4 bits of a data. So here the data bits are at position D3, D5, D6 and D7. So I am taking the input from the user at position 3, 5, 6 and 7. Correct. Now I will be calculating the parity bits. So please look at the screen and see how this data 1 is P1 parity bit, right? So as I've already informed you, whenever I'm going for P1 parity bit, I will be considering all the data bits at odd position, right? So I'm considering D3, D5 and D7. Correct. So this is how D3, D5, D7 is calculating, right? So with this, I will be getting the parity bit for P1. Then I am calculating the parity bit P2. Now P2, how the P2 is calculated? As I have already explained you, consider 2 bits, escape 2 bits, consider 2 bits, escape 2 bits. So I will be considering P2, I will be considering P2 D3. Now P2 is the parity bit itself, so I will consider D3. Then in supposed to escape position P4 and D5, so that positions are escape, and D6, D7 is consider. Correct? So this is how the parity bit P2 is calculated, and P4 is calculated with P4, D5, D6, D7. Correct? So this is how all parity bits are calculated, and encoded data will be displayed on the screen. Correct. Now what we are supposed to do here, we have calculated the parity bit at a transmitter end, right, or at a sender's end. Now as we are simulating the Hamming codes, right, so we are simulating as transmitted the data and the data also received at receiver end. So this is all is simulation through programming. So now at a receiver end, see, we will consider that the data has been transmitted, and now we are only the receiver, and we will be considering the data at receiver end. Fine. So here we are prompting the user again to enter the data at a receiver end. So whatever data is received at a receiver end, that is also entered by a user as to simulate the Hamming codes, right? So here we can enter the data at a receiver end, right? Now the same data is to be verified, whatever is received at a receiver end. So we will be calculating this bit C1, C2, C4 as considering with the parity bits, right? So how to calculate this C1? Now this C1 is to be calculated with P1, D3, D5, D7, right? As we have already seen, correct? Similarly, C2 is calculated with P2, D3, D6, D7, and C4 is calculated with P4, D5, D6, D7, right? The way I have explained you in the Excel or in the theory, we will be calculating this bits C2, C1, C2, C4, and then converting them into decimal, right? So this is a simple formula to convert them into decimal format, right? Converting a binary number into decimal. So this is how we are converting binary number into decimal, right? So let me explain you again with the theory. So let me go back to the theory. Fine. So here, see, this is what is I will say this is my C1, C2, and C4. Correct? Again, I will write this as C1, C2, and C4 to sync with the code, right? So this is how this C1 is calculated from the code, C2 is calculated, and C4 is calculated, right? And then we have seen here we need to convert it into decimal to check whether the error has occurred or not, right? So we have converted this binary numbers into decimal using the formula that C1 into 1, C2 into 2, and C4 into 4, right? So that is how we have converted it into the binary for decimal format, right? Now after converting into decimal format, if it is 0, if this number is 0, it means that there is no error, right? We can see it very easily from the code also. If that number is 0, it means that there is no error. So let me go back to the code again. Fine. So we are at the code again. So what we are going to check, if this particular number is going to be 0, right? ये decimal जो convert किया है आपने, if that particular number is going to be 0, then it means that there is no error in transmission of a data, right? And if it is going to be some number, right, then there is a error. We can easily relate this to the theory, because suppose if all parity bits are 0, it means that everything is even parity, which is already decided by sender and this receiver. It means that no error has occurred while transmitting a data. If any of the bit from C1, C2, C4 has become 1, it means that the data has toppled, and that's the reason we have get the odd parity somewhere in between, right? And that's the reason we need to calculate now where at what position the error has occurred. So suppose this C is not equal to 0, it means that error has occurred at some position, correct? And then how to correct
Hello,
that
ma'am.
error?
Your screen is visible. Ma'am, your
Yes.
screen is shared, but it's not visible for me.
No, ma'am, it's visible.
Hello, ma'am.
Okay. Okay. The screen is visible. I think there is some end at the student. There is some network problem at a student end. The code is visible. Is the code visible to all of you?
Yes, ma'am, it's visible.
Okay, fine. So I will be sharing the code also later on with all the students. So that time everyone can refer to the recording and the code, right? I will be sharing the recording again. So at the receiver end, we can see that the data which is received, correct? Now what we have to do, we need to find the position of erroneous bit, right? So what we do, we will complement it and find out the position of the error bit. So this is how we are complementing the position. We are checking whether at which position data has occurred, and now the data is corrected, correct? So this is how the Hamming code works. What we are doing, we are simulating the performance of Hamming code, or we are simulating the generation of Hamming code, and then error checking and error correction with Hamming code in this particular code. So let me show you the execution of a code. So let me go back and share my command prompt. So this is my command prompt. I hope my screen is visible. Now command prompt is visible with all of you. So I will do dir. So here I am having the Hamming code uh, C file of a Hamming code. I will again execute this in front of you. So GCC minus O, we can say that Hamming code, and then let me compile the C file, Hamming code.c. So my code is getting compiled and my executable file as a Hamming hyphen code is getting generated. So we can see that this Hamming hyphen code is generated today. See, we can see the date of execution is 30, date of creation is 38 2021. So let me execute this code. So Hamming So enter the 4 bits of data one by one. So what I will be doing, I will be entering my 4 bits of a data. So let me take a data from the example itself. So it will be easy for students to go in sync with that. So my data from the example is, my data is 1101. So let me enter this data 1101. So you can see here the parity bits which are generated as 100, correct? So encoded data is 1010101. Fine. So this is what is the data which is we are supposed to send to the receiver. So this particular data is transmitted on a transmission media. And now as we need to simulate the error correction and error detection, we are supposed to enter the data again. So let me enter the data. So I will enter the same data. So because to show that, see, 1 0 1 0 1 0 1. So I have entered the same data. So it has said that no error while transmission of a data. Now let's check with the erroneous case, right? So I will execute the code again and enter 4 bits of a data one by one. So let me enter the bits again. So they are 1 1 0 and 1. Fine. So now you can see the encoded data is 1010101. So if I want to introduce the error at one of the position, so now I want to check with the error case. So I will be entering the erroneous data. So 1 1 1 0 1 0 1. Right. So this is my data which say I have received at a receiver end, and let me check whether it is correct or incorrect data. So I will press enter and we can see that error on position 6. So the data received is this and the corrected message is 1010101. So this is how my Hamming code works. So today we are done with the Hamming code explanation, theory explanation, the code explanation, and with the execution of Hamming code.